This time on Captain Castle's Laboratory, we are working on the Black Cauldron Inn. This was sent in with a list of issues. Don't have the list next to me. But witch doesn't work, ghosts don't work, I think one of the lights don't work. Well, anyway, we're going to check it all out. And I have a tip so you can see it. Let's turn it on. I have not turned it on yet. So, let's see what it does. It's weird, they're all working. But it's also tipped, which isn't working, and the ghosts are jerking. So let's turn it right upside up. Because sometimes when you have like a broken gear, changing the angle, which shifts the amount of gravity it takes a hold of something, yeah, you can see they're jerky, affects components. So the witch is not going in, the ghosts are jerky. One of them is missing apparently. I did not see it in the box. Let's just double check the box real quick. And here's the list too. Nope. Box just has a leaf from the display. It says ghost not rotating at top. Oh, ghost ring at tops are jolting. Witch no longer goes in and out of door. Cauldron light by front door is out. So there's the issues. So they're probably referring to that. And this looks like it's been worked on once before, because we got hot glue and the cauldron's not centered, as well as the bottom. There's no screws and it's all glued shut. So it's been opened at one point, just fine. It just means that we may not find the OEM stuff in there. Now, for those who don't have this piece, this was made in 2002, and it is a 3-volt unit. So that way, if you do have this piece and you lost your power supply because it uses this in line, 9-volt ones also, some of them came with that in line. You put 9 volts in here, I guarantee you nothing's going to work. I'm going to grab a spudger, and I'm going to start getting some of this glue out of here. You can reheat this to get the glue. Normally you would just take the 3 screws out, but like I said, somebody glued the whole bottom in. The reason I'm not going to reheat it is this whole bottom is plastic, and the heat to get the glue to break free can also distort the plastic. So I'm trying not to damage anything as far as, and all the components should be attached to this base. Well, or the majority of them, let's rephrase that. There we go, broke free. Just to give me a little more movement. Now, things like this, when whether it's the witch on here or the old guy, the mortician, and the mausoleum piece, sorry. If they're stuck out, which seems to be the way they always fail, makes it a lot more difficult to remove the bases. So if you can, sometimes you can put a little pressure and get the piece to move just enough that you can pull the bottom out. And that's all I'm trying to do right now. This is the problem when they fail in the out position. We just need this door to flex just a little more. There we go. Okay. So here's our guts. Let's get some of this glue off. So we have a small hobby motor driving through a small gearbox, which these gearboxes were known for failure. That then moves a plate back and forth, which has teeth on it. But the track is I don't know if you'll be able to see it with the wires, but the track isn't attached. So that's probably the issue with why the witch isn't working. So let's find out. And then the ghosties have their own motor up top. And then we have a broken wire right here and right here, which those go to the cauldron. So I think we found the reason why we're having some issues. So now I want to see if this actually tries to move and it's just this broken track or this. I'll turn it down so we don't have to hear a speaker. The speaker is an 8 ohm 0.4 watt speaker, slightly smaller than the standard, which is usually a 0.5 watt. Not a big deal. This light's not doing anything. There we go. Now it's flashing. But this motor is not moving at all. The wires are soldered. They're not broken from the board and they're not broken from the motor. Let's see if the motor's getting powered. It might just be a bad motor. So I do get 1.6 volts for a moment as it's going through its cycle. I'm at 0 right now. .6 volts. So the motor is reversing and going forward. It's in preset cycles from the circuit board. So, sorry, the power is going to the motor. The motor isn't doing anything at the moment. I don't hear it, I don't feel it, nothing. So, probably have a bad motor. Now we're going to see about getting these ghosties out. The motor for the ghosts are tucked up inside at a very, very hard spot to get to. And what I'm going to do, and this I'm doing just to get this out of my way and not break the wires loose from circuitry, is I'm going to cut the wires to the top. I'll know which one goes where because one's white, one's green. And I know which one goes to here because I know these are white and green because these go to the cauldron. So here is the inside. It might be hard to see. The ghosties are up in here and they're up in there. And they have a motor. I can see the bottom protruding through the plastic base. And this disc that's white, you can see the seam around the edges, is just glued in. So I'm trying to see if we can get this to break free and slide in, but that's going to be the problem. This doesn't move. So I might have to, that might be why the ghost is broken. I wonder if somebody tried to fix it. They ran it to where all the ghosts were behind and just popped one off. So you can try that. That came off pretty easy. So now, I don't think they pulled this out, but I do need to try and rotate these ghosts. So if you try to take this top one out, you're most likely going to have to break a ghost off, or if you can heat it enough, heat it to where you can get the ghost to come free from its glue. At least one of them. And I need some power. There we go. Don't stop. I'm not running it at full power, just running it enough to where I can try and rotate. There we go. I was only running at 1 volt. If it's the same motor as that one there, it's probably running closer to 1.5. So since that one ghost is missing, once I turn all 3 ghosts to the back, it just slides out from under this front piece. And now it's loose inside here. Now I gotta figure out how to get it out of here. Make sure there's nothing that's gonna break. Might have to take 2 ghosts off. The ghost sticks so far back when it rotates, it's actually too far back. So let's try and rotate it a little bit more. Basically, the clearance in here to pull this out of the hole in the bottom is very, very tight. So if you don't have a power supply and you were doing this, one where you have variable voltages, a AA battery or a AAA battery or a C or a D, any of those or 1.5 volt batteries would work fine. Because like I said, I'm running it just over, it's 1.1 volts to be exact is what I'm sending to this. And this motor can handle technically up to 3, but the circuit board I think is only sending it 1.6-ish. Probably is 1.5, just a little overpowered. The 3 volts, they spin a lot faster. And then this is one of those like old toys where you gotta find the right angle to get the thing to do what you need it to do, which is come out. And it's on the bottom now. Now I just need it to twist and turn and fit out the hole. Here we go. Now I'm gonna move the house out of the way. So yeah, these are the same. So because these had a problem with the gearboxes, I'm assuming this one's got a broken gear and this one probably has a broken motor, or it's just really quiet and the gearbox is also broken. But you can see this doesn't have a lot of glue. It's still the original, it's yellow. There's none of the clear stuff like right there that's more modern. And with one ghost off, you can get it to slide back. Then if you can rotate it, you can then get it to slide around where the ghosts are at their smallest off this plate. Because if this was at 90 degrees, the ghost is out here and then it interferes. Once I got it to rotate where it's the smallest, I was able to pull it down and then twist it out. So putting it in is going to be a treat. And this had the option for a screw in the center, which there isn't one, so I'm not sure if they took one out or not, but without it, you can slide the ghost off, which technically would make life easy. You think, oh, I can just pull this out the bottom. No, you can't. There's a lip. So you can't pull it out the bottom, and you can't lift the ghost out the top because you have the actual house itself right there sticking out. So you do have to be a little patient and finagle it around a little bit. So this is using 4 clips to hold the whole assembly in. And a lot of times they glue them, so I'm just going to see if there's any glue on these clips. Yes, there is. Because that's what makes it so hard to take this thing apart to check the inside, is they use hard resin glue to hold these clips to the body. Our equivalent, if you were going to do this at yourself and fix this, if you had to take this part out, is super glue, Gorilla Glue. Instead of screwing around with that, let me just take the gearbox apart and see what the insides look like. So for that, you need a small screwdriver. See, is this one too big still? No, that's the right size. And whatever you do, do not lose these screws. You probably will never find them unless you have a house that has these gearboxes in it that you can scavenge. They're such a small machine thread screw. Here we go. So the gearbox on these uses 4 gears that are exactly the same. They're just stacked. Those are your transfer gears. Except this one uses 6. Interesting. So I guess I was wrong. Every one I have is 4, but it's okay. This one uses 6. They're still all the same size. And generally you'll find one of these is cracked, and that's what causes the jerkiness. So the last gear is always pressed on, and this one's the one that's broken. I need something to clean off the excess grease. This will work. Okay, all these gears are good. This one's bad. So let's check this one. This one's good. So here's the gear. I don't know if you can see. I need a pointer. This will work. If you look right there, it's missing some teeth. Yeah, right there. That's why it's jerky. Gears don't like to be missing teeth. Just a thing on how they work. So, I'm going to have to see what I have in my micro gears, if I have one this size. If not, I'm going to have to change the whole gearbox, which is going to change the speed at which they rotate. So for the moment, I'm going to put all the gears in there, and I'm going to set this off to the side. I'm going to put the 2 screws next to it. What I want to do is listen to this motor, because this motor was loud, but I think the loudness was the gear, the broken gear inside chattering. I just want to make sure this motor is clean and smooth, and it makes no noise. I'll pump it up to its full power at 1.5 volts that it gets from the system. It's drawing a 100th of a volt because there's no load. Put a little load on it. It stalls at 600ths of a, sorry, 100th of an amp. It stalls at 600ths of an amp. So this motor's fine. The noise I was hearing from the motor was the bad gearbox. Now let's look at this guy. One, we have a piece of track that's not attached right in there. And two, this motor isn't doing anything. Now you can test the motor by sending power to it. If you do that, you need to cut one of these 2 wires off the motor. You don't want to put power backward into the circuit board. That would be bad. This motor, they glued an LED to. So we're going to take the LED off the motor. First thing I'm going to do is try and remove some of this hot glue, which this hot glue is newer than the other glue, so I'm assuming this was part of its previous repair. There we go. So LED's off. And this motor is just glued all the way around to the brown base. And this piece that's not attached, I believe attached to the door. Yeah, it's snapped off. So this piece right here was attached right there to the door, and it is sheared. So most likely, so here's the sheared end of the door. Kind of see how it's lighter plastic. So most likely something got wedged, probably the witch got wedged, and when the door tried to close on the mechanism it broke, or when it was taken apart it got jammed. And I don't think the glue on the teeth is going to help this motion any. So do the same thing. I'm going to take it apart from the gearbox. I don't want to break the adhesive that's on the track. And the same thing, try not to lose your screws. If you want to cheat and you're sure you're not going to lose your screws, you can just stick your screws to the speaker. It is a magnet. It'll hold them right there on the back. So this motor looks good. Now we need to take out all the gears and see what's going on inside the gearbox. This one only has 4, which is what they normally have. And the 4th one is pressed on, which it's supposed to be. So that bottom gear looks fine. The gear underneath looks fine. Everything's good. I'm going to say we just got a bad motor. So we're going to desolder the motor. We're going to send power to it and see if it works. I doubt it does. Again, you don't want to send power through the motor backwards to the board. So if you were to put 1.5 volts on these 2 connections right here, actually I'm not going to desolder, I'm just going to cut them real fast. I want to wait for the machine to warm up. And there's plenty of wire slack. And 2. Now, the model of these motors, and you're going to have a hard time finding them, is FF, like Frank, 030PK, like Paul, Kit Kat, or Kilo. The secondary number is B like boy, N like Nancy, 819915. And the reason I'm going to tell you you're going to have a hard time finding these motors is because they don't really make them anymore. Also, broken plastic inside the housing doesn't help it any. This broken plastic is the alignment for the drive shaft, the drive of those gears. So that's a problem. We're gonna have to try and fix that too, or else the gears will just wobble. If I have a complete replacement gearbox, I'm just gonna replace the gearbox, because fixing these small gearboxes is really, really tough. So now let's test the motor, see if it spins. It is spinning. It is pulling twice as much as the other motor. It's pulling, instead of a 100th of an amp, it's pulling 200ths of an amp. If I put load on it to stall it, it stalls at 800ths of an amp. Let's reverse the polarity, because they are reversible. See if it changes. Yeah. So I'm wondering if the reason this wasn't working is not that this got a bad motor. This motor is super quiet too. They both have bad gearboxes. So what I can do is I can take one of the gears out of here and put it in there to fix it, or swap this motor, which has 2 good standoffs on it, for axle alignment, and make this work, and then just rebuild the other one that has the broken pieces. They are the exact same motors, aren't they? Yep, FF 030 PKs. And then this one has both good standoffs. This one has all good gears. So I can literally just swap this motor here, and then I'll have to deal with one issue. And that's what I'm going to do. Some of these older Lemax houses were really interesting in the fact that that's how they did things. They would use the same assemblies at both ends of the house, because they usually ran 2 or 3 or 4 of these setups. The Mausoleum used 1, 2, 3, 4, and Dr. Stretch and Pulse Torture Factory used 1, 2, 3, 4, 5, depending on which generation you had, motors to run stuff. Now on those, only like 2 of the motors were interchangeable. There we go. said don't lose the screws, but apparently I lost one. Oh, there it is. Out of sight. When putting the screws in, just make them snug. Do not over torque them. The aids of these things, you will break the plastic. And then you're going to have bigger issues. So, let's just see if it actually, which goes out. Which goes in. So what I would do is just solder, I can solder these wires to those, or I can just desolder these and stick them on here, doesn't matter. I would take this glue off. This glue wasn't used to hold an LED like this one, this other motor had. This glue was just because it was up inside and they didn't want anything touching the bare copper or bare tin contacts, which is to prevent it from causing a short, which is a back feed or an overamp, can blow the circuit board. It doesn't blow the circuit board in the sense that the circuit board explodes in little pieces and you're all destroyed. It's just a little blob chip that fries, and then your stuff doesn't work anymore. So at that point you can make it light up, and that's about it. You can make the ghost continue to spin, but anything else would cease. So there we go. Stuff's exposed. One last thing we're going to do, because I am going to stop it and look for gears and stuff to fix the other motor, because that has to go in first, of course. Let's see if this cauldron light works. And if you don't have this piece, the cauldron says, trick-or-treaters welcome. It's got a bone sticking out like a stir stick. And the two headstones just say RIP on both of them. And of course it says Black Cauldron Inn across the top of the door. And that's pretty much all the features for those who don't have this piece. I have this piece. This is not mine. Mine still fortunately works. But it's an older piece. You can tell by the paint job. I mean, 2002 was over 2 decades ago. And it's not a bad piece. I actually bought it because it's, I like the old style Victorian houses. And I like the fact that the newer ones that are, I know a lot of people don't like it, but made out of plastic, they actually look pretty good. Okay. No light. Could just be the wrong polarity. LEDs have a polarity. If they're backwards, they don't turn on. And still no light. Well, this cauldron's cocked at an angle and I can see all the glue underneath it, so why don't we pop off this cauldron off and actually see if the LED is not blown. There's the LED. Okay. This is a replacement, this isn't the original. And their glue job, you can see it's very big. So the green wire is the negative, the white wire is the positive, because I can see the LED now. Let's try it again, and let's connect it right to the LED itself. There we go. So probably just have a bad solder joint. They're really clumpy. It might be called what they call a cold joint. A cold joint is not something you smoke that's been in the refrigerator. Oops, touch the two leads together. A cold joint is where you have solder on it, but the connection underneath is horrible. You didn't get penetration into the metal for adhesion. So it probably just got a cold solder joint. So this does actually work. It's just, it just needs a little TLC. And I'm going to remove both the new and the factory glue. So we have a nice smooth base that we can readhere it with. That way it'll look good and fit better onto its little platform, which has a little bit of residue that we're gonna just pop off. Right there. So we're gonna make this house as good as we possibly can with the parts that we have available to us. Also, stuff like this I like to repair outside of the house because it is a porcelain house, and just maneuvering it, you might slip and your thumb might hit the columns on the front and you break a column. You might pop off a headstone, one of the ghosts on the patio, or any of the number of spires and chimneys. So anytime I have a porcelain house, if it has to be fully disassembled, I like to remove all of it, then repair it, and then finagle it back in so there's less chance of damaging the porcelain house itself. Porcelain isn't forgiving. That's another reason I like the plastics. It is because the plastic houses are forgiving. Now, if you drop them off your workbench or your display, they may still shatter, but there'll be less pieces that you'll have to deal with. All right, I'm going to pause this for a moment, and I'm going to try and locate something, whether I have the original 6 stack or if we're going to change it to a 4 stack, and try and repair this whole assembly. And I don't know if you could have seen it, but we're going to show you. This tube right there, it's kind of hard to see, it's right here. The one that's right here is broke off and stuck in the gears. What those tubes do is the axles, the shafts, slide in and it keeps them parallel. So if the one's broke, the gears are no longer parallel and they bind. Which, surprisingly, didn't happen up here, because when they bind, that's how you break the teeth. I don't know how that one has broken teeth. This one surprised me, it just stopped and it went to a stall. Which also surprised me, because when the motor goes to its stall, it's pulling the highest amount of amperage it can outside of being dead shorted, and yet the unit still turned on. A lot of the newer Lemaxes, if you have them or you watch other videos, when the motor goes to a dead short or a over-amping state, you lose functionality. This one, the Ghost still tried to work with broken gear. The lights inside worked, the music worked. You just didn't have the cauldron light because of a bad solder. Well, they're not hooked up. And this didn't work because it was wedged. So, more functionality on this older piece than on a newer piece, which is surprising. So, anyhow, so I'm going to work on finding some parts for this real quick. And then we're going to have to figure out what we're going to do about this door. I don't have one of these as a parts piece. I don't even think I have a door like this. But we'll see what we can finagle, what we can do. We can glue it. The only thing we risk is if we glue it out of angle, the door will either try to pull shut further than it's supposed to and break, or push open further and break. So, well, that'll be one of the last things we deal with. And then as far as the cauldron goes, I'd have to try and turn mine on and see it. That room is a little hard to see at the moment. I think this is just always on. I don't think it turns on and off. So this, we can just wire to direct power. So wherever direct power is on the board or off of the switch for the power, we can just hook this up to. And that way it's always on. Personally, I would have gone with a green light versus a white light. And make it look better, but that's how it is. So, alright, be back shortly. Okay, I've gone through some of my stuff. I found 2 different micro motors that are still attached to gearboxes. This one's a 4 gear, this one's a 6 gear, this one the gearbox is cracked, this one that thing is seized. It's still parts, something I can hopefully use to fix those. The boxes are the same, these are just clear, but so you can get an idea, since this one's broke open. All the gears are the same size, and you can see how it reduces the speed. Let me zoom in to below the light. There you go. So they're all the same size, but you can see as you get closer to the front, they start slowing down. And that's just gear reduction. All right, I'm going to zoom out. Now this is running them at 3 volts, which is the maximum. If I bring it back down to 1.5, you can see it's quieter and slower. This one, though, just draws a buttload of power but doesn't rotate. So it's wedged. That or the motor seized. Those all turn. Oh, yeah, that motor's seized. That's why it draws a lot of power and nothing happens. There we go. Just got to break free. So it's still a good motor. I'll put it back in my pile of motors. Yeah, no, it's a bad motor. She doesn't start. And at 3 volts, it pulls a 0.5 amp. So this is a bad motor. It does happen. Not much you can do about it. But this motor is the replacement for the F, which is an even smaller motor, which was used in some older stuff. And it's hard to find. So that one's trash. But what's nice about this assembly here is these all should be the same gears. They are. So now I can replace that broken gear because I have spares. The fun part is this gear that is bad is pressed on to the armature. Normally you just slide them off, not a problem. On these small ones though, they're a little bit harder to get off because they want to distort. So you got to be a little more careful, I guess. The problem is getting to them. Well, gear definitely doesn't work now. There's part of it right there. Can I just break the gear off without bending the shaft? The gear was damaged. We just need to get it off of the metal shaft without damaging the metal shaft. On a full-size motor, it's a lot easier with full-size gears. Also, it's not recessed in a housing, which makes life so much more fun. Shaft still appears to be straight, which is good. Yeah, she still spins straight. Okay, make sure you have no broken plastic pieces inside. All good. So this does have a spacer for the extra gears. Like I said, they usually only have 4. So the spacer popped off, not a big deal. Because normally the screws are short, and that's because it doesn't need to go through a spacer. But apparently this one wants to be different. So let's take a good gear. We're going to take this good gear off of this shaft. The reason being is they're all the same gear as far as their teeth, but this final gear is just a outer gear. There's no inner smaller gear, so it's not a step or nosed gear. You put one of those in, and then you risk the height being wrong. Huh, that actually landed in my gears. That was pretty good. So the smooth nose goes down. Sticking it on is easy until you get to the knurled section. So it slides straight on, and then you hit the knurled section. The knurled section is the part that actually holds it. Keeps it from spinning on the shaft. Let's see. I don't know if this is deep enough, but we're going to find out. It is. So you want to push it on as equal as possible. So I'm going to use a small. Actually, I think I have one smaller nut driver. There we go. Yeah, it's one size smaller, which will push on the gear. And I'm going to put the nose down and use that as the backer. We're just going to carefully press this on. It's almost on. It's on part way. Alright, I've maxed out this nut driver. Let's see if this one's any deeper. Yes, this one's deeper. So the non-metric nut driver has a deeper setting. Now, the gear is on. And now we're going to build the gear stack. Or we're going to try to, put it that way. Get back in there. Would you? Thank you. Boy, it does not want to stay in its bottom port, I'll tell you that. There we go. So it's just alternating. You go the nose gear, then the other shaft, and then the nose shaft, and then the other shaft, and you're just stacking them. Shows the other shaft likes to wobble since it doesn't have as much support because it's not pressed into anything. There's our 6-gear stack. And we put the spacer on. The spacer can only go on one way because it is like a Lego. It's got bumps on one side and recessed areas on the other. Now is going to be the big problem. The big problem is this plate. These plates are not screwed on. They're actually glued onto the motor. And I need one that has both axle tubes. Because this is also a 6-gear pack. It's going to have the long screws. This one has the full setup. Looks like the same drive gear. Well, let's see if they line up. Color doesn't matter. One's clear, one's not. There we go. Now, we'll screw it back together, and then we'll fire it up and see if it actually rotates. Oh, it came out of its port. There we go. Now, as far as these gears go, if you have a broken one, you are going to have a hard time finding them. They're micro gears, and they do have micro gear kits out there. I have not been able to find a gear kit that has the same size gears as the Lemax gear packs go. So that's usually why I just scavenge old houses. There we go. But eventually somebody will find the correct one and it'll be better. Ooh. It's not turning. It's over amping. So I have a funny feeling it probably fell out of the bottom hole again. Means it's wedged. Yeah, it's not aligned. I think I got it back in. It did for a second. Here we go. It's turning. Now let's make sure it turns when I put the screws in. clear housing is thinner. By putting the screws in, it's compressing it too much. So they're too tight. Let's give it the correct voltage. There we go. But you can see that it actually does turn. It is louder, but it's all new gears. Well, it's a combination of new and old. So, okay, so that part's done. So next is trying to figure out what I'm going to do with this door. So bear with me for a moment. I'm going to clean some of this up and I'll be right back. Alrighty. I have cleaned up the mess. And I did go ahead and solder on the wires to the motor. So looking at it, when I soldered the wires on, I also broke this motor free and cleaned up all the glue. Just some stuff that's just dead time since this video is at this point is just under 1 hour. I think the best way is to make sure the witch is at its fully extended or recessed position, and then trying to super glue the bar back onto the base of the door. That looks like the best option. But let's make sure that it does its thing. It's just really loud. I don't know how much it picks up on the camera, but that's a really loud speaker. But there's no house around it either. I think I just tried to pull the witch in because she just went backwards the half a tooth and lifted. That's interesting. I wonder if that's why it broke. It is because it's using the plastic housing to stop the witch from going forward, and it overextended because now it doesn't reach. Because when it goes back, it hits this big housing the motor's attached to. It doesn't have a micro switch or anything, so it literally just pulls the motor over amps and then it turns off the power to it. I'm going to let the witch go back in. So I'm going to have to glue it, and then it's going to have to cure for a while. That glue's got to be super solid. There's a lot of stress on that little piece. That's crazy. So that's probably why it broke. Like, no joke. I thought it was kind of strange. It just had this motor that went back and forth, but it didn't have any way to tell the circuit board that the motor's fully retracted or fully extended. And it doesn't. It just goes, figures it should take 2 seconds, and so it sends power to it for 2 seconds, even though it takes 1.5 seconds. Whew. It's a cheaper way of doing things, but you then also encounter problems like this, where it breaks things because it's always under stress. So I use the super glue from Gorilla, so it's technically Gorilla Glue, and I like to use the yellow cap because it has a brush, and that's just preference. You can use the blue. I have the blue cap too. The gel works decently. I'm going to put a little on the door and a little on the bar that actuates it. That's why I like the brush, is because you have better control, especially since you're doing it underneath the platform or in between the two edges. We're going to, oh, it turned, come back, there you go. We're going to try and stick this on. You know, whenever you're trying to do something that's on a time schedule, because you've got glue on it, it decides it doesn't want to work. Now we just need to wedge it into place. So it's underneath, it's just too low. And I just need to push it off of the side of the plastic so it doesn't glue to the housing. Like that. If you have bad eyesight, I would highly recommend magnifiers. That's what I'm actually using right now. Because, yeah, this is some fine, intricate work. And you can't see it all. There we go. So now it's centered. Now I'm just going to make sure by using the razor or X-Acto knife that there's no glue in the small gap between the housing and the pin. That way it doesn't glue the door permanently. So once this is done, I'm going to let it cure for a while. I know this will cure in a couple of minutes, but I'm going to do probably a half hour or so, because it's under a lot of stress since there's no stopping that motor. That's a bad thing. I'm thinking if it tries to break it again, maybe fabric cobbling something to stop the bar before it gets to that point. So where the witch bends down onto the platform back here, you can put something across that hits this bar, a piece of popsicle stick as an example, a thin skewer from or wooden toothpicks. Something that hits the bar and stops it, which means it might click, before it hyperextends this joint where it pivots the door. Might have to do that, where this is going to be a test trials, basically, to figure out what to do. So that's the reason it probably broke. The plastic's gotten brittle, it's old, it's 22 years old. The motor runs until the circuit board timer tells it to stop, because there is a timing chip. There's a black chip right here. That black chip is a timing chip. That black chip times this motor and this LED, so they work together. It's just got two different sets of wires because the motor pulls more power than the LED. LED runs at 1.2 volts, the motor runs at 1.6 volts, and also if you put them together, the LED would get bright, the motor would spin slow, so they're on two different tracks with isolators. They've got Zener diodes and resistors, of course. So basically that timing chip says, okay, 2 seconds, or I didn't count the time, but we'll just use 2 seconds as a good number. But in actuality, like I was saying, it only takes 1.5 seconds or 1.8 seconds. Well, that other 0.2 to 0.5 seconds as it's running. So the motor is supposed to bind and overamp, but instead it was jumping the teeth on the gears. It's jumping on the bar that has teeth on it that goes back and forth. And that's probably because of age. Every time it does that, it tries to wear more and more of the plastic off, and then eventually it'll slip. And that's probably why it broke the gear inside here, is because the timing is off. The timing could be off because the components around the timing chip are fatiguing, which means that its duration is too long, or this had an additional stopper that isn't in here anymore, and because it broke off, didn't get put back in the last time this was opened. I can't give you an answer. But there is no part on here that tells the motor to stop except for that timing circuit. So the timing circuit is out of time, or the assembly is out of time due to something's missing, and not a micro switch that tells it what to do. So somewhere in here When it goes all the way forward, it's causing the bar to flex, and that's why it was click, 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 click. But when it pulls it back, it doesn't, because the bar doesn't flex. And it could be because this wasn't attached, this bar here that does the door. So I'm thinking there's going to be too much stress, and it's going to fatigue the glue joint. The glue joints work really good, but they're not permanent. I don't even know it says permanent glue. The glue joint will either fatigue and re-break because it's under stress. Glue is supposed to hold two things together, but not necessarily two things that are under constant stress. You glue your coffee mug back together, the stress it has is heat and cold, and eventually it will come back apart. This is under torque, where it's being pushed and pulled, so it's the wrong kind of stress. So we need to mitigate how much gets put on that glue seam. Next case of the scenarios pool would be that it doesn't break at the glue, it breaks above it, like where the door goes through the platform. And that would be even worse to try and fix, because now you're trying to glue it through the platform. The next option is to remove this whole assembly and maybe take a metal rod, like an axle shaft from a motor, because it's hardened steel, or a gear pack, and rebuild this whole thing. But the problem is that piece of metal has to adhere to the plastic, and even though super glues will bond metal and plastic together, the bond strength of two dissimilar materials usually isn't as good as the same material, and that's not always the rule. There are exceptions. So you can rebuild the door by removing the plastic pins and making it a solid metal pin, and then just gluing the door to the pin so the door just flaps back and forth. But the door isn't the stress point. The stress point is the pivot down here, where this arm pivots and then has a pivot joint to make the door swing open and close with the witch. To me, there's probably other ways to make it work too. The mortician on the mausoleum piece, the rest in peace mausoleum, the two doors open because the platform helps push them, but there's also springs on those doors. There's two little springs. So as the mortician comes back in, the springs are what close the door. You could probably fabricable something out of here, because this platform right here is very large, and you could drill a little hole off to one side. There's already divots, but ooh, did I knock it out of alignment? There's divots, but I don't know if there's full holes, and you could stretch out a spring from a pen or something. No, it's still in alignment. And make it so the door no longer has this track, and the witch pushes the door open, which means the door would be rubbing up against the side of her body, and then when she comes back in, the spring pulls the door shut, like an automatic door closer on your screen door as an example. So that's an option too. And we have a couple of different options we can do to try and fix this. So we're going to try the original setup with the bottom piece re-adhered to the base of the door. If that doesn't work, then, or if it snaps, depending on how or where it snaps, I'll probably go with the spring option, because that'll be a little bit easier and has longer life than making the bar option that goes all the way through, because that bar still has to adhere to that piece. That's the point of where we have problems. And then I gotta quit smacking this thing. Luckily it's somewhat glued, so I can readjust this to keep tension on it. There we go. And you could even, where this pivots, I'm going to use my fingers, I won't hit it, there's a plastic rivet right there. You know what, let's zoom this thing in while it's drying. A lot of technical mumble jumble. I can only zoom it in so far because I really don't want to push this back. So you got a plastic pivot right here, which is riveted. You could possibly even attach the spring to the pivot point onto the inside edge of this door. It'll still close, even though it's not on the far side or in the center like on your screen doors, as an example again. So there's another option. And you don't have to use a spring. You could technically just use a piece of string, wire, something, because this plate moves back and forth with the witch. So if the plate goes forward, and it's like a solid bar, it'll push the door open. The plate goes back, it'll pull the door shut. If it's a piece of string, when the plate goes forward, the witch would push the door open, and when the plate goes back, the string would pull the door closed. So, like I said, there's definitely options here, and yes, that hole right there does go all the way through. Now that I'm standing, I can see right there, and there's another one right there that also goes through. So I'm wondering if this setup at some point in a different piece of different rendition or different design had springs. So if this was a tandem door like the Rest in Peace Mausoleum, the springs would attach on opposite sides, pull each door shut. And that's how they work. So I'm really wondering if they designed this with springs or a bar, a metal rod, at some point in its inception. Or if this is the same piece used on another door, another Halloween piece or a Christmas piece or an Americana piece, so on and so forth. So, and since we're kind of zoomed in a little bit, in case you're trying to figure out how this is working, is this spudger is underneath right here pressing on the pin, and then it's not touching the mat. It's suspended right here is the fulcrum point. So the weight of the entire spudger, let me zoom back out, wrong direction, really good at doing that. So the entire weight of the spudger is pulling down, which is pushing that bar up, pushing the door up to its maximum compression to keep that glue joint intact. The pliers are underneath to give it lift so it can do the fulcrum. So just in case you've never done anything like this, that's what it's doing. So here's the edge of the plastic. Let's say this is the spudger, and then here's the pin, and I'm basically just doing, I don't want it to fall on top of the unit because it's round. Let me try something not round. A little exaggerated too. So it's doing that, and that's what I have down there. So like I said, I'm gonna let this cure for a while. I want to make sure that glue is absolutely everything solid, and then we'll try it again. I don't have the aerosol spray that makes it cure instantly, so gotta do what I gotta do, which is just let it cure naturally. If that doesn't work, we'll design something else. So it's gonna be a long video. Wasn't intended, but sometimes that happens. And then hopefully when we're done, we'll have a fully functional, back to almost OEM Black Cauldron Inn. So I shall return. Okay, it's been a little bit more than half an hour. It's actually been a couple of days because things got in the way. So it's not been touched, it's just been sitting here. So let's see if it works. Just turning the sound down a little bit. Well, I don't see any movement. Door's not glued shut. Yeah, I don't like that. Apparently I didn't wait long enough, but I don't like it jumping the teeth. I want to wait for it to close. This thing apparently takes a little bit. So, there's something off in the timing. So something's off in the timing for the speed of the motor. I'm wondering if we slow the motor down a little bit, if it'll not do that. And how we would slow the motor down is with a resistor. Well, the door works. So gluing the door and apparently letting it sit for a couple of days did a pretty good job. Normally I'd only let it sit for a half hour or so, maybe a day at the most, but things got in the way and I couldn't get back to it. So let's take a closer look at this and see what we can do about it jumping the gear teeth. I don't want it to break. And it's doing it in both directions. So, looking at the track, making sure it's using all the available teeth that are on the gear for this movement. So it's all the way back and it's at the last tooth, it appears. And I'm not talking about the tooth on the motor, I'm talking about the tooth on the actual track. When it goes all the way forward, it's skipping on like the second tooth in from the back because this bar has pressed up against the door. So if we can slow the motor down, if we slow it too much, it won't go all the way in or out. If we slow it down just right, it should hopefully stop it from jumping the teeth. So what's going to happen is it's going to break either the tooth on the bar or the tooth on the motor. Neither one of them would be good since the housing is glued together, and to break it apart, fix the broken tooth or gear or slide, you then have to glue it together and make sure you're in perfect alignment. And I don't see any bosses that it fits in. It's just kind of eyeballed. It's pretty close to square, but it looks like it's a hair off. So as long as the teeth engage, I guess it's fine. So, all right. So we got the door fixed. We got that motor fixed. We got, well, technically both, because we mixed gearboxes. And like I said, all the gears are the same size, so I didn't change the ratio. We know why this doesn't work. We know it does work. So we're getting there. The process of elimination on parts. And we got some sections done. And then we just got to figure out what we're going to do about this. So this is going to be an issue, apparently. And I still have to get this back up inside with the little ghosties and get the wire soldered back on and make sure it spins in the right direction. So we got some work still to do. I know this video is getting long. Let's get the machine on. There we go. I need to do is figure out which side is the correct side of the motor for the rotation of the ghosts. Okay. Put the white wire in one side. We're going to turn it on. I'm going to take the green wire and touch the other. And that is correct. So the green wire goes here. So we got the right rotation. There we go. So now I know what side to solder, because we're going to solder these wires on. Now, if anybody has this piece, I thought I did, and I don't know. I can't get into where I have my stuff at the moment. I don't ever remember it clacking like that. I also don't remember the witch being that fast. And that could be a couple of different things causing the speed. That could be maybe the new motor spins a little quicker, or maybe I don't want to say the gears because it's the same gears. Should probably see if I can find if I own this. I got so many and I got to keep better track. So if this is mounted in this way, like that, then I need the wires to come back. So, if you somehow reverse the wires and the ghosts were going the wrong direction, if you didn't want to try and remove this assembly from up in there, you could technically just cut the wires, switch them, and then put them back together. But that's why, since I have this all out, I can test it to make sure the ghosts are spinning in the right direction. Because that's kind of sort of important, you know, if you want it to work. What I'm going to do is I want to compare the motor speeds and see if maybe the new motor is just faster. The original two motors had the same exact part numbers because they were made by the same exact manufacturer, whereas the new motor, if I remember right, has a different part number. No, never mind. I thought it did. No, they're the same. Oh no. This one's a PA, FF030PA. This one's an FF0C30PK. So one's an apple and one's a kilo. So it's possible that maybe the PK is a faster spinning motor, which in that case would mean that the door would be faster, which means that timing circuit that it uses would, well, still send the same amount, but it's moving at a quicker speed. If that's the case, might just have to change the two motors. Because there's our speed here. There. And I just noticed the witch had an apple in her hand too. Ha! This motor seems like it's a lot faster. If the ghosts spin quicker, that's not going to make a difference, but with the witch moving in the door, that's too quick. The joys of doing this is figuring out how to adjust for aftermarket or new parts, since the OEM stuff never exists. Not on these, since they're not designed to be fixed. I like how the ghost thing keeps moving from the out of balance ghost, because there's one missing. So, come on, go back in. It's not a self-resetting piece either, so that's some important information. Okay, so even though I know I just soldered the wires, let's go ahead and swap the motors and see if that does anything. I'm just going to disconnect it from the power, so if there's any residual power coming through, it doesn't get arced when I desolder these wires and switch the motors. I'm going to have to desolder the wires on this thing too. Alright. There's one. There's two. There's one. And there's two. One of the gear axle doesn't want to go in its hole. There we go, I think I got it. Nope. So I got the one that didn't want to go in, and now the one that did go in didn't go in, of course. There we go. All right. Magnet on the screwdriver is crazy. It sticks to everything. Okay. This one went together a lot easier. I don't know why. That one didn't want to line up. And I'm going to have to do the same thing as far as this motor. I'm going to have to see which direction is correct. Since of course I desoldered it. But I want to see if it spins slower. So I'm just going to tack the wires on with solder, and then I can mark them afterwards. And the reason being is because this motor already had solder on it. I can't slip it through the little eyelids on the back. So if they spin backwards, and I'll fix it after the fact. Okay, here we go. Oh, well, they're spinning the right way, so I can mark it. They seem to be spinning faster. It could just be my imagination. There we go. Okay, that's a positive. It didn't click, and it stopped before it hit the end of the track. Now, let's see if it does in the other direction. So apparently you need the PA motor on here, not the PK motor. So apparently those are speed differences. Hey, look at that. Let's let it do one more cycle and see if that was a fluke or if it actually worked. If it actually worked, it's time for reassembly. If it's a fluke, then we got to figure something else out. And it seems to take forever. But I'm curious, what's this one? This one is unmarked. Unbranded. Hey! That's a good sign. Come on. finish your cycle, go back in. There we go. So, we now know, you watching and me actually doing the work, that if you have this piece, if you have the Black Cauldron Inn, the motor that drives the witch needs to be a lower RPM motor, and apparently you need to get the FF030PA, so Papa Alpha, for the last 2 digits. And I am not going to lie, FF series motors are sometimes getting harder to find because they've been replaced by their bigger brothers, which don't fit in these micro gearboxes. So you might have to, well, depending on what it is, you might have to scavenge, or you might have to just not have that part functional, which I know is bad to say, but a lot of these motor companies don't make large batches of motors, and there's no replacements because, well, they're just hobby motors, and most companies just figure it's a hobby motor, who cares? You can just put any motor you want in there. But when you have old electronics that are using the speed or RPM of the motor as a determination of, distance, like in this case, how far will that travel, then it poses an issue. But on this piece, if this motor is locked up, you can pop this motor off and swap into the faster motor up here. But you have to take this thing apart, and as you swap off, you watch the beginning part. That in itself can be a wonderful little treat. Now, as far as slowing motors down, I tell you never to slow them down with a resistor like I was mentioning, but I'm talking on a hobby motor, I don't think it's going to make much of a difference. There's motor controllers out there, but motor controllers generally don't run at 1.5 volts, or 4 volts, or 3 volts, like the incoming power for this thing. They usually run at like 12 volts or 9 volts. They run at standard DC hobby voltages. You could always try and put one of those in there. And then the motor controllers I have won't go down to 1.5 volts, meaning the output. So you can't control a 1.5 volt motor, which is what these are running at, 1.6 to be exact, according to the meter. So, yeah. But if you have this piece and this motor dies, swapping with that motor means you have to take this whole house apart, which is a treat especial, and then you can get the faster RPM motor, because they're still hard to find. They're not labeled, they're just blank, and pop it in here, because if the ghosts are spinning quickly, it just means they're on a rush to go around the house. It's not like it matters. Okay, now let's see if I can get, oh, it's so close to where I need it. I just gotta tap the ghost over just a little bit. Again, if you, let's try it. You should be able to rotate the ghosts with a AA battery. I think I mentioned that a little bit ago. Let's see. I don't know which is positive and which is negative, so I'm just going to hold the negative on with my finger. There we go. So you don't need a power supply like I have. Because this is low voltage, it's 1.6 volts, and a AA battery says 1.5 on the side, but a good AA battery will have right around 1.8 volts. It's plenty of power to make that motor spin, especially if you're tapping it. And that goes with AA, AAA, C, and D. Don't do a 9 volt. This little motor is not designed for that. You'll actually potentially damage the motor. But what I have is the biggest distance here for me to get this back up inside. And I'm probably going to have to rotate the ghost again to get it to fit through this casting, right here. And as you saw, if you are doing this yourself at home, you can use a AA, AAA, C, or D battery, as long as you catch your leads though they're long. Now comes the, let's figure out the angle to get this thing back into its place. I really wonder how they do this in the factory. Alright, so I got the ghosties in there, but with the non-functional ghost being the missing one on the back, I can't get it in, but I have it up to the part where I can hopefully rotate it again. But I need to lift it so it doesn't rub the... You know what? Let me try this. Need smaller hands. Let me just put this one over here and see if I can just do it without having to rotate it twice. If I can do it without having to rotate it twice, that means you'll be able to do it without having to rotate it twice. Oops, a little too far. There we go. Yeah, because there's no need to go buy expensive stuff like a big power supply like I run, if you can do it at home with other things. Like my LED tester, you might have seen in other videos, is just a 9-volt battery with a resistor and a Molex connector that you can get from, well, this little motor has one. Yeah. So sometimes you buy stuff and it comes with them that you can just cut off. So my hands are slightly too big to fit in here, so I'm going to use the needle nose to see if I can give me a little bit more assistance in getting this thing lined back up. With the ghosties though, it's not wanting to go. Let's try it backwards. Hey, it went in, but it fell. It's kind of in, it's just sideways. The round part's facing up, but it's getting there. I need longer needle nose. But take your time and patience and all that to try and do this. Or if you have somebody else who's got small hands, say, hey, you can do something for me. Reach up inside and get my ghost plate back in. There we go. Bam! Alright. So, ghost plate's back in. And no matter what you do, you are going to have to remove a ghost. Like I said, this one came missing a ghost. But if you have this at home, you're going to have to remove a ghost. The ghosts are glued on. I can see on the back side, and you might be able to see on the edge, there's a little dab of hot glue where they glued the ghost on, or acrylic glue, or acetate glue, super glue, whatever you want to call it. So now I'm going to get my hot glue gun hot. And then I'm going to try and lift the plate and squirt underneath it and then push it back down. The reason I recommend hot glue and not using something that would be easier, like Gorilla Glue with the brush, especially the one with the brush, because you can just, and you're good, is it's going to break. It's going to break again. There's nothing you can do about it. Anything electrical, mechanical, hydraulic, will fail at some point. Even if you repair it, it's going to fail again. I'm sure a lot of you folks out there know you have a car and they constantly break or they need upkeep. So even though it's got a newer motor, it's still not a brand new motor because they're so hard to find. I still want to make it where it's repairable, where hot glue, you can heat up the area, since this is a porcelain or ceramic house, and you can heat up the area a little bit, not enough to warp the plate, but enough to start getting this glue to break free so you can push it out. And if you want to make yourself a little easier, you can remove 2 of the ghosties before you do all that, and that way you're less likely to discolor or warp one of these ghosts and then push the plate out or pop the plate up, so on and so forth. Also, if you have 2 of them missing, it'd be easier to put in. So, but minimum, you have to remove 1. Maximum, you can remove all 4. I don't know why you'd want to do that, but, you know, to each their own. Now I just need to wait for this thing to get there. It's getting there because the tip is no longer solid glue. I got a little drip from what was left over from the last time I used it. Get it off. So it is the end of May, and I've noticed that Department 56 and Lemax have started releasing their stuff. I know that a few pieces are available. I got a whole bunch of emails in the last couple of days saying 2 pieces have been released, buy them now. So for all you Halloween folks, hopefully you're buying everything that you want. I'm going to soon. I got a few other things I got to take care of before I spend money on Lemax. I just bought a whole bunch of Department 56, and they're usually generally more expensive than Lemax, so but I don't know what everybody collects, but I collect whatever fancies what I like. And I also collect Ghostbusters, and since Department 56 has the Ghostbusters and they just released the last of the series, that's where I spent my money right now. I'm gonna lose my drip here. There we go. So I just pushed the plate back a little bit so I can get to the edge. I'm not going to glue a whole bunch of the plate. I'm just going to glue around the edge on the inside. And it might look like I'm doing a lot of glue. I'm actually hardly pulling the trigger just so I have a very, I'll say a very thin bead until I said something. And now we're going to slide the plate back in. And rotate it to the correct position. And now clean off the excessive glue. And that's just so it doesn't hit the little track or the little bars that the ghosts are attached to. There we go. And to make sure it works right, meaning it's not smacking or binding, let's connect the wires. Yeah, I can't get the battery in there because one wire is too short to come out the door, so I was going to do it with the battery again. That's fine. Just do it with the meter. Yeah, the wire is a little too short to come out the door far enough for me to connect it to the battery. But that's okay. You guys get the point. So I have my machine at 1.5 volts, and there we go. They're working, they're not hitting the house, they're not interfering with the glue, which I removed the excess, they're not interfering with the center section right here. So we're good to go. If you're new to the channel, I recommend testing the pieces along the way so you know if something binds or gets screwed up in the process. So next, we're going to feed these wires back through the opening in the front here, and we're going to readhere this cauldron correctly. I'm not going to use hot glue for the cauldron because hot glue is thicker, so it lifts, and that was the biggest issue there. But if it's still warm enough, I am going to put a little hot glue on the solder joint, and what that's going to do is prevent them from creating a short. Normally I'd say arcing, but at 1.5, at 3 volts, it's not going to arc, it's just going to create a short. So that's just to keep the solder joints from interfering. And I'm going to use the brush. So it's going to take a little bit of time for this to cure there. So while it's curing, this white light needs to run at 3 volts to turn on, which is the full power from the AC adapter. So I do not see anywhere on the circuit board where it wasn't originally attached. So I use my magnifying glasses and I look for a solder joint that's been broke or has a stub of wire sticking out. Something that tells me, hey, I was here once and I'm not here anymore. So I don't know. It looks like it may have come off 2 contacts right here on the board. Good, I did disconnect it right there. Because those 2 solder joints don't look as good as the other solder joints. But when I go to this side, those 2 solder joints are sharing the timer. From the timing chip. So I don't believe those are correct. But what I want to find is the incoming power rails. Now this has 5 wires, they're all green, and 2 wires are hot and negative, and the other 3 wires control the speaker. So I'm going to say that this one is hot. I could be wrong, but we're going to voltage test it with, or we're going to test it with a meter. And the reason I say this one's probably hot is the ghosts get direct power. Here's one of the ghost wires right here, and that's the plus. And this wire has a red stripe on it. Red stripes generally mean hot. Not always, generally. So if that's the case, then I can solder onto the hot, because the light just needs to be on, because that's what it does. And then if that's the case, then I'm going to say that the outer rail over here is, nope, that's not negative. Negative would be the outer rail over here. And the reason I can verify that is this capacitor right here, the negative is attached to this rail, which also has another capacitor and the ground pin for the timing chip. The timing chip has a negative and a positive. So we have a good inclination that that is the negative rail. So we're going to test it. So how we test it is get our meter out, and it's on DC. There we go. I hit one of the buttons and changed it. It's easier just to turn it off and turn it back on than to go through the selector to get back to the beginning. And we have to turn it on. Now, careful. if you probe around in here and you slip and connect two contacts together that are not on the same rail, you can damage the circuit board. So just don't, just be more mindful of what you're doing. Power's on. So we're going to go over to the negative, which I believe is right here. This should be the positive right here. Yep, 2.9 volts. So just to show you again, positive. Negative. Okay. So and I'm wondering if this, because this is a positive, there's a hole in the solder. It could have just been a bad solder joint. I'm now wondering if this and this were soldered together and it broke. Since the ghosts always run, but the ghosts run at 1.5 volts and the light runs at 3. So I don't know where the ground would have been. I don't see another pockmarked solder joint, but I believe these two shared the same power point. So let's get the meter off the bench. Got the solder machine up and running again. And is this cured? Yes. Shoved wires in and they went up instead of sideways. That's nice. There's one. There's two. So we're going to solder those directly to the circuit board. Now for the two wires that go up to the motor on the top here, we're going to use a little heat shrink to protect where they're going to get soldered back together. So there's our heat shrink. We need to solder. And remember, before you solder, slide your heat shrink on. If you don't, you can use electrical tape. You can use hot glue, which Lemax is really good at doing for solder joints. And kind of like I did right here for the cauldron. And you can also use liquid electrical tape, which is a black paste type material that coats the wires. You just need to trim the end of this wire so it fits. There we go. There we go. And this is where things get a little fidgety because you only have so much wire and so much space. Sorry, trying to move my chair and got caught in the grout line. So I'm going to do the cauldron first. And if I remember right, the cauldron was green was hot and white was not. Because that's how the rest of this is. And I'm probably going to use some tweezers. That way I can hold it and still see it. I'm not blocking it with my hand. Because I need to be able to see what I'm soldering. get the wires back together. They're all frayed. There we go. When you're soldering on a circuit board, make sure the power is unhooked. You don't want capacitors to, they should discharge naturally, but you don't want them to go through your meter and onto another track they're not supposed to be on. And you don't want to put heat or arc, because even with the switch off, there's still power on the board. And a lot of these, not all of them, but a lot of them, especially the ones that have sound. So first things first, we're going to tin the wires. Then I'm going to solder to the circuit board. I need to see my negative track again. Yeah, it's that one right there. I lost my negative track. There it is. All right. So here we go. Let's get this thing back together again. And I'm going to hot glue that light back on once I get the stuff soldered. I'm going to tip this up so I can see it in the light. And I do have enough slack, which is nice. I have a wire in my way, so we're going to tip that wire up. There we go. So there is the negative. And the positive I'm going to try and put back on with the other wire, since that's where the pock mark is. And technically anywhere on the track is okay. But let's try and go back to original. Now, how I do junctions is I twist the wires together and then I solder them. And then I fold them over so the heat shrink will slide over the junction. And instead of doing them tip to tip, I find that folding them over works easier, and the heat shrink compresses it better. So if something fails like a cold solder joint, the heat shrink will keep it good. There we go. There we go. Now I'll push the heat shrink up. Now you can use the heat shrink to shrink it. You can use a lighter, or some people use the end of the soldering iron. I don't like that. But you can use a heat gun or even a hair dryer as an example. But before I actually shrink it, I'm going to turn it on one more time, make sure everything works. All I'm going to do is slide the heat shrink over to prevent it from touching anything important and potentially arcing or shorting out. So that's all I'm going to do. I mean, it's tight enough already. Technically, it would be okay, but we're still going to get it with a little bit of heat. Cauldron's not on. Okay, that's weird. I'm getting 3 volts of power. This is why we test things. So either the solder joint's bad, or I don't think that the hot glue did anything it shouldn't have, unless it's crap. But let's see. Wait for the witch to come back in, and I'm going to turn it back off. I'm going to move the ground. Apparently the leg I have it on isn't constantly 3 volts. The ground fluctuates between 1.8 and 3, which is why the cauldron's not staying on. I'm going to move it to the actual ground wire coming in from this, which is 2 pins directly below where I have it soldered currently. So sometimes it's trial and error. Just gotta wait for my machine to get hot. I'm also reheating the glue to glue that light to the top of the motor. Okay. So, let's do this. It's getting a long video for such a small piece, but everything has to be worked on this piece. So if you're still watching, I appreciate it. If you've skipped ahead, it happens. If you've quit, that happens too. Disconnect that like I always say I do. I just want to make sure I didn't make a solder bridge. Yeah, I made a solder bridge. Solder bridge is where you connect two pins together with a solder joint, and I have a solder bridge. I'm not using a fine tip, and this is, should have changed it before I started. Alright, so now it's just time for some reassembly. You always want to make sure that witch's door is closed if you can. You just got to glue the base on, but let's make sure that the door is lined up. I think we're good. Except that stupid cauldron not turning on correctly. Thing's gonna drive me crazy. I'm wondering if I should have touched up the solder joints on the back of that LED. There's always something. just going to keep the volume off. No, I don't have to hear it. There. That's the hot. That's the not. Got 3 volts. So there's 3 volts going to that LED and it's not turning on again. It flickered and then it went out when I tipped the house. Oh. I think I know what the problem is. I bet you I have a reverse polarity. So the white goes where the green is and the green goes where the white is. So my soldering iron's still hot, so I'll just swap them real fast. And before I forget, let's do that since I'm going to be working on the main track now. And there's the white wire. Let's get that white wire off. Like that. Let's put the white wire up here. So I'm wondering if the flicker, if this is the case, the flicker I might have saw might have been like this light when I pointed it in, might have reflected in the, I wasn't looking in the cauldron, I was looking behind the cauldron where I can see the actual LED. So ooh, that could have been hot. Gotta re-wet that. And the white wire. I don't recommend doing that, but when it's still hot enough that the solder is melted, using your fingers to flatten it out. If you have nerve damaged fingers, you won't feel the heat, but you can still burn your skin. Well, that's not good. The I've soldered it so many times that the solder track has broke free. So let's fix that. So this is just a flex pen, just adding flex to the area. I can get a little bit better adhesion. I'm going to re-wet the tip. I need these, and I need that broken solder joint right there. Put that down before I burn myself until I can get this into where I need it to be. Lead you over here. There we go. Ooh, all right. You need the witch to go back in so I can try and fit it. Thank you. Now the light works when I pull it out. It didn't work when I had it in. Oh, I see why. Let's turn the power off. There's a bridge from the previous, whoever tried to repair it before. When I pushed it in, it touched. I can see it. Let's get rid of that solder bridge. Now let's put her back in. I'll have to re-glue it, of course. Hey, and I got white light. Good. And yes, apparently it was reverse polarity, since once I reversed the polarity, at least I got light again. So let's get this back out. Let's get the hot glue gun going and glue the bottom in, and let's take a look at this thing in the dark. So, pause it for a second while my glue cures, and then we'll turn it back on and see what it looks like in the dark. Be back in just a moment. Okay, now we're in low light. It's as dark as I can make it. So the LED flickers, which I think is weird. It is on. It's just you can see it flickering. So this is what it looks like in low light. Doesn't look bad. So I think I have this piece. I just don't remember. I'm trying to work on that room and getting everything displayed again. Yeah, the light flickers with the thunder sound. But doesn't look too bad. The witch comes out. I think the reason the witch clicked is because I turned it off in its mid-cycle, so it had to reset. But I'm going to watch it for a little bit and make sure. I usually let these things run for at least a half an hour after I fix them. So I'm going to sit here and watch this, and if it clicks again, I'll pull the bottom off and see what happened to the timing. But it's probably because I turned it off mid-cycle, because it goes in just fine. And then I'm going to see if I can get the LED to stay on and not be attached to the lightning effects, because like I said, you can see it flashing. So other than that, she's good to go. So sorry for the super long video. I know some folks don't care for the really, really long ones. I didn't expect this to be nearly 2.5 hours. Okay. Oh, it's on the sound circuit. Yeah, I gotta fix that. No problem. All I gotta do is move the one track. But other than that, there you go. We have a fully repaired, well, excuse me, 99% repaired. I just gotta move the one wire over. I stuck it on that ground track that I was talking about. That ground track for the sound circuit, I need to move it over to the ground track for the power cable. There's 2 of these 5 wires that are marked for ground, and I picked the closer one, the one that was easier to get to. Apparently that's for the sound chip, which is why the light's on now. When I turn the music on, it goes dim, which is not a big deal. That's kind of how equalizers work with the flashing lights, where it bounces to the music. It's attached to the sound circuit, so I don't want that flashing like that. Not a problem though. Easily fixed. I just move it to the other ground since there's 2. But, oh, when I turn it off mid-cycle again. Damn it. The motor that's in here, the one that I replaced that was bad, and the gearbox, like I said, they're really, really hard to find. I took them out of other houses that I use as parts pieces. They're FF series motors. They're difficult to locate. All I can tell you is try and search if you have a house like this that has those micro motors, and see what you can find. If you come across something like the Ghoulish Gourd or Dr. Stretch and Pulse Torture Factory, and it's broken, you might want to buy those for the parts because they use the FF motor in both those. And the same gearboxes. Some are the 6 stack, some are the 4 stack. But if you have a broken gear, you can swap it out like this one had. As far as the door goes, I think it got jammed and then it broke the plastic off. Super glue took care of that, and the door's working like it's supposed to. If that piece is sheared off to the point where you can't fix it with super glue, ballpoint, one of those click pens where it has a spring inside, you can take that spring and stretch it, cut it, and then attach it to the door on the inside where the witch is. So kind of down in this area, and then attach it to one of those 2 holes. I'd do the inner hole here, so that way when the witch comes out, it pushes the door open, and when the witch goes in, it pulls the door shut. You have to adjust the tensions. If it's too strong, you're going to be making that motor strain, and if it's too light, it won't close all the way. So when you get a spring like that, when you cut it, because both ends are tightly coiled, you have to cut one off that's not tightly coiled. You may have to cut another coil off. Start too long and work your way back. A lot of the other door opening and closing units have springs on them. If you have one, look at the spring and you'll see it's just a really, really small spring that's attached to the bottom of the door in 90% of the cases. Sometimes they're attached in the middle, which is not as common. So, and then if you lose an LED, whether it's one of those 2 orange ones, the green one, or the white one, you can easily replace them. They're standard LEDs. The orange and the green run at about 2 volts, and the white runs at the full 3. You can get a lower voltage white that runs at 2 volts. I don't know if I'd recommend it, but if you do that and you connect this to the track it's supposed to be connected to, since I do not know which one is the correct one since it was already disconnected, if you get a lower powered white, you would have to run a resistor, or else you would pop the light. So, but other than that, if you watch this whole video, because I know it's like 2.5 hours long, it's crazy. That's how you take this one apart. It's a long process, and this is why sometimes it takes so long for the videos to come out, is because they literally take me hours, or in some cases days, where I'm waiting for parts, or I get to the point where I gotta stop, move it aside, do something else to clear my mind, and then retackle it. This one I never did that. I just let it sit on my bench. My job got in the way for 2 days, so there was 2 days where I didn't touch it, and now we're back, and it's basically finished. I just got to move the solder joint on this, and it's good to go. So what sucks is I already glued the bottom on, so now I got to peel it back off. But it is what it is, and that's how it works. So at this point, it's pretty much done. I'll fix it off camera. You already saw me soldering 100 times when the track had an issue, so we'll call it good. And until the next one, thanks for watching. Quick addendum, light's fixed. It does go dim when the motors turn on to move the door. It doesn't go out, it just gets a slightly dimmer. And and that's it. So it kind of flickers, but that's because of the draw. And I noticed that the amber lights do the same, but I just moved the ground track off of the sound track. So they're not sharing the same ground. That way there's a little isolation between, and there you go, nice and white. So yeah, the green showing, and unfortunately the paint on the cauldron is getting thin, so you can see through the cauldron too. You saw how it flickered when the witch just came out. That's what I'm talking about. It just flickers when the motor kicks in. But if you pay attention, the amber lights do the exact same thing. So anyhow, just showing it's fixed, fully functional, ready to go back to its owner. Have a good one.